This is really the first interesting problem on the 2019 MIT Integration B qualifying exam, and the solution to this problem is like our solution to the Gaussian integral. So I'll link the video on the solution to the Gaussian integral below this, and if you watch that first, then you have a shot at doing this on your own. Yeah? Okay, cool. All right, let's begin. So to start, let's focus on the exponent of e here, so this exponent. And note that negative 2019 divided by 4t squared is the same thing as negative 2019 over 4 times 1 over t squared, like that, right? Okay. Yeah? Okay, so this here is the same thing as this here, and therefore the exponent on t is the same thing as this here. Now, I wanted this because I'm going to make a u substitution to begin, and I'm going to let u equal 1 over t. Now, I've said in many videos that I have videos teaching you how to pick u when you're doing u substitution. So yeah, you should watch those and understand why this is a good choice of u. And this is a good choice of u because of this t squared in the denominator. As you'll see shortly, it's going to work out nicely with this t squared in the denominator if you choose u to be 1 over t. Yeah, okay, now with this choice of u, then notice that du is going to equal negative 1 over t squared times dt, right? Okay, and then multiplying both sides of this by negative t squared, notice that negative t squared times du is going to equal dt, like that, right? Okay, cool. So we're ready to rewrite the given integral, but there's also one more thing we need to discuss, which is since the integral came with limits of integration, what happens to those with the substitution? Well, as t goes to 0, u goes to infinity. And as t goes to infinity, u goes to 0. Meaning our integral is going to be infinity to 0, and then e to the negative 2019 over 4 times 1 over t all squared, but 1 over t is u, so u all squared. Now do you see why this is like the Gaussian integral? And then dt is negative t squared du, so negative, so times, right, times negative t squared du, right? And of course we still have here in the denominator our t squared. And this is what I was talking about earlier. Now you could do this, right? And you could put this negative in front of the integral, right? And scoot the du closer. And remember, you could swap the limits by taking the negative of the integral. How nice. So we could get rid of this and write 0 to infinity, right? Okay, and from here on out, it's very much like our solution to the Gaussian integral, right? And yeah, this is what we're going to do next. Next, we're going to say that I is equal to this. And so then I is also equal to 0 to infinity e to the negative 2019 over 4 v squared dv, right? And so if we look at what I squared is going to be, first, is going to be the integral from 0 to infinity of 19 over 4 u squared du, and then times integral 0 to infinity, same thing with the v, right? E to the minus 2019 over 4 v squared dv. That's I squared, right? But because of property of sigma, which this lowercase sigma adopts from the capital sigma, because they both add, right? You can go from a product of sigmas to a double sum, and therefore we can go from a product of these integrals to a double integral. So we're going to say that I squared is the same thing as 0 to infinity and then 0 to infinity e to the, and let's, you know, in the interest of space and time, like time space, let's like use our exponent rules and note that like this times this is the same thing as e to the minus 2019 over 4, and then it's going to be u squared plus v squared, right, and the exponent du dv. This is really like the first time I've ran out of space. Du, actually not true, my apartment is tiny. Okay, there, yeah, okay, now what, right? Now what? Well, now we switch to polar coordinates, right? And yeah, so using polar coordinates, we know like x squared plus y squared is equal to r squared, right? And so that means that in this case, you know, who cares that we're using u and v instead of x and y? It means that u squared plus v squared is equal to r squared. And we also know in polar coordinates that I should have like put this a little to the left. U squared plus v squared is equal to r squared. But we also know in polar coordinates that du dv is going to turn into r dr d theta. On my solution to the Gaussian integral, I explain why dy dx turns into r dr d theta, and so same reason for why du dv turns into r dr d theta. So watch that video. Yeah, okay, cool. So then we have to worry about the limits, right? Okay, now look for the limits, it's doing this, right? Which is like, if this is the u axis and this is the v axis, u is going from 0 to infinity and v is going from 0 to infinity. So we're talking about this first quadrant, right? Okay, so in polar coordinates, this first quadrant is this, right? If we have theta go from 0 to pi over 2, right? Theta goes from 0 to pi over 2, and r goes from 0 to infinity, right? R goes to 0 to infinity, then we will have represented the first quadrant in polar coordinates as opposed to the u and v rectangular coordinates, right? Okay, so what I'm saying is that for r we should go from 0 to infinity, and for theta we should go from 0 to pi over 2. So if we do both, right, then I squared is going to equal first, sorry y'all, what's the order here? Theta comes in last, so 0 to pi over 2, that's what I was trying to figure out. Okay, and then 0 to infinity for r, as we said, and then we have e to the minus 2019 over 4 instead of times u squared plus v squared. Now we have r squared, right? Okay, cool. And then we have, instead of du dv, r dr d theta, r dr d theta. Okay, so to continue, we have to first deal with this integral here, right, concerning r. And so for that, let's make a mini u substitution. And so this time let's use w since we're running out of letters. If we let w equal negative 2019 over 4 r squared, then dw will equal negative 2019 over 4 times 2r dr, right? And then the 2 and the 4 here can take care of each other, so we can write a 2. And now if we multiply both sides by 2 over negative 2019, we're going to get 2 over negative 2019, and then it's going to be divided by r, right? So times 1 over r, and then times dw is equal to dr, right? Times dw, this here is equal to dr, right? That's what we'd have. Okay, cool. So what we do is we go I squared is then equal to 0 to pi over 2, and then 0 to infinity, and then well, actually we're ready to do the integration, right? Well, no, we still need to do the substitution. E to the, remember, w was this exponent of e, so e to the w, right? And then e to the w, and then r dr, well, the r is unaffected, but the dr is right here. So that's 2 over negative 2019. So let me write I squared, make room here, 2 over negative 2019 right here. And then 1 over r, so times 1 over r, and then times dw, right? Times dw. Cool. So we go, oh yeah, r times 1 over r, that's gone. And so the rest of what we'd have is this. And what about the limits of integration? Do they change for w? Well, we could abandon them for now until we get back to r. So I could just do this and then get back to r and then evaluate from 0 to infinity once I get back to r. Yeah? Okay, cool. So that means, first, what's the antiderivative of e to the w? It's just e to the w. So we'll have I squared is equal to negative 2 over 2019, and then 0 to pi over 2. And then we just said that this is the same as e to the w, but that's e to the negative 2019 over 4 r squared. That's what w was. And then evaluated from 0 to infinity, and of course then we have d theta, right? Because the integral about theta is not done. Okay, now what happens when we evaluate this? So if we like plug in infinity, we're going to get e to the negative infinity, which is 0. E to the negative infinity is 1 over e to the infinity, which is tending towards 0. So it's 0, right? And then we go 0 minus, remember, I got this 0 by plugging in infinity. I have 0 minus, what about when I plug in 0? And technically, like, you know, when I plugged in infinity, it was being multiplied by this constant, right? Okay, so when I, let's keep that in mind. But yeah, it's fine, I could keep the constant outside also. Yeah, sorry guys. So we have 0 once infinity is plugged in, and then when I plug in 0, I get e to the 0, which is 1. So I have minus 1, right? So this whole thing just turns into negative 1 d theta once evaluated. So I go, this is the same as negative d theta. Okay, so yeah, I realized I didn't need to talk about being multiplied by this constant, because we already took it out, and that's fine. And it's really so you understand why this negative is going to disappear now, because there's a negative right there, right? Okay, so doing that now, I have d theta. And what's that? It's going to say I squared is equal to, actually I want to move over here if that's okay. It's going to say that I squared is equal to, it's equal to 2 over 2019 and then times theta evaluated from 0 to pi over 2. So I squared is going to equal, when I plug in pi over 2, what am I going to get? 2 over 2019 times pi over 2, right? When I plug in 0, I'm just going to get 0, right? 0 times, yeah? Okay, now look here. This 2 and this 2 cancel, and so I have a 1 and a 1 there. So I squared is pi over 2019. Pi over 2019. Cool. So the finish, I is equal to the finish. I don't know if that's, I think that's like a person from Finland. Sorry, I meant the end. Pi divided by 2019. Yeah? Voila.